So our arm is turned on, and you can see this is the default position, all joints at 1500. Let's take a look at that. Now, it's important to see the current draw at this position, which is 1.4 amps. Always good to have an analog meter, in this case a 5 amp analog meter, in series with a power supply to always monitor the current. Now, what we are going to do is look at the Power Raptor. So the Power Raptor at this point is been brought up, and you'll notice that the device address is empty, and we're going to scan for devices, and you see that all these addresses show up, which are the addresses, the I2C addresses for each joint, each servo in the arm. So very interesting, very good way to control a arm through I2C, because you have direct access to each individual I2C device, and each individual I2C device has its own unique address. So let's go over here and show the Power Raptor. So the Power Raptor is the Ionotronics USB to I2C SPI bridge, and it is connected to this bus here, which is our 6x6 I2C buses, specially designed to drive the PIC 16F1825 modules here, which support them in terms of 6 volts supply, onboard 5 volt regulator, and the 6 volts is used to power the motors on the arm. So each one of these servos is powered through one of these devices. So let's take a good look at the units here. So these are all our units. Now, each one of them has a 6-pin Mullux connector. Now the red wire in this case is 6 volts. However, white is data, blue is clock, and black of course is ground, and they all are connected through Mullux connectors. We have a wire protector here to our bus, as you can see. Let's take a good look at that bus. So this bus is supporting 6 degrees of freedom in this case. All of them are used, and we connect the Power Raptor, as you can see, directly to the 4-pin Mullux connector here. Okay, right here, and it controls the robot. Now we are going back to our scan of the I2C bus, and we can manipulate each individual servo through its I2C address. Now, rather than do that, we have a tab which is called PWM Servo Control. And this tab allows us to control one individual servo. Now, if I go to this tab, this is to control the whole arm. We have nice controls for each individual servo on the arm. Also associated with each one, we show the I2C address. We are interested, of course, in the elbow here and the base. So let's go ahead, and if the base, take a look at that, the base I2C address is 5.8. Zoom in. So the base is 5.8. Take a look at the rest. We'll go back to our PWM servo and type in 5.8. So we will be controlling the base. So you can control an individual joint or servo. Now we are going to go ahead and put this all the way to the end, which is 2400 microseconds, and we will say to time it for 5 seconds. So when it makes a move, it'll make a move for 5 seconds. Now that might be an initial condition. Let's go ahead and press the update. And let's take a look at our arm. So it did move. Now what we're going to do, because there was an initial condition which was a previous timing, let's go ahead and move this all the way. So let's move it all the way to 800. Let me show that. So now we're setting the PWM to 800 microseconds. And I'm going to park the cursor on the update button. And let's go ahead and look at the arm as it moves, the base. Okay, so The base is very sturdy, operates very smoothly, and can handle quite a bit of load. That's why we designed it. This is a specially designed base from Ionotronics. Visit our website or contact Ionotronics for more information. Now what I'm going to do is tell the arm to go in the opposite direction, fully opposite, which is 2400 microseconds. I'm going to park this on update so you can see that's 2400 microseconds. I'm going to park this on update, and let's go take a good look at the base and the robot and hit update. There you have it. So let's go the opposite direction. Now I'm also going to go midpoint. Click on update. Okay, let's go all the way to the other side. All the way to the other side. Now I'm going to change the timing to 1 second. So what we need to do is move it all the way in the opposite direction. We've set the timing to 1000 milliseconds or 1 second. I'll park this on update, and let's go ahead and take a look at the arm, and it'll take 1 second to make a movement from one end to the other. Pretty smooth and fast. Now there's going to be, of course, some vibration in the arm. I'm going to go the opposite direction. So I move the lever all the way to the opposite direction, park it on update. Let's take a look at the arm. Okay, let's go ahead and make it 2 seconds. So now I've set it to 2 seconds. Go ahead and hit update. Okay, let's go the opposite direction. So this is our base, very sturdy, handles a lot of weight, and smooth operation. No squeaking, no need for oil or anything. Contact Ionotronics.